Good morning. Today we are going to talk about the basics covered in Physics 1. So let's start with the basics. Trigonometry, or how I like to remember it as SOHCAHTOA. Let's begin. So we have a right angle triangle with a given angle theta, and then the three sides adjacent, opposite, and hypotenuse. To be precise, this side is opposite to the angle theta, and this side is adjacent to the angle theta. We have our three trig ratios: sine theta, cos theta, and tangent theta. In higher level math, you will learn three more trig ratios: cosecant theta, secant theta, and cotangent theta. However, we will not discuss that today, as that is for another day. So let's start with sine theta. Sine theta is the opposite side over the hypotenuse, or as you'll remember, the SO part of SOHCAHTOA, sine opposite hypotenuse. And then we have the other two, cosine theta and tangent theta. Cosine theta is the side adjacent to the angle over the hypotenuse, hence the ka part of SOHCAHTOA. And then lastly, we have tangent theta, which is the opposite side over the side adjacent to the angle, hence TOA. Alright, so suppose we had to solve questions using trigonometry. Let's say I was given a right triangle, and the angle is given of 60 degrees, and then we have one side, we have the opposite side, root 3. So where do we go about solving for the hypotenuse and the adjacent side? Let's start with solving for the adjacent side. Recall, since we have root 3, recall that tangent theta is the opposite side over the adjacent side. Now we have theta, which is good, and we also have root 3. So now all we gotta do is solve for the adjacent side. Here we go. Tangent of 60 degrees equals to root 3 over a, the adjacent side. Now, in a physics course, you will need to know algebra. Physics and math are strongly connected. So we need to isolate for a. So for starters, let's multiply both sides by a so that a is in the numerator. Now that the a's cancel out on the right side and we have a on the left side, we get a tangent 60 degrees equals to root 3. Now, let's solve for a. If we divide both sides by tangent 60 degrees to solve for a. Therefore, a equals root 3 over tangent of 60 degrees, and the tangent of 60 degrees is root 3. Therefore, you get root 3 over root 3. The root 3's cancel out, and you get 1. Now, there are two ways of going about to solving the hypotenuse. For starters, we can use Pythagorean theorem. Recall that Pythagorean theorem is, in terms of trigonometry, it is the adjacent side squared plus the opposite side squared, which gives you the hypotenuse squared. So we just solve for the adjacent side, which is 1. So thereby we get 1 squared plus root 3 squared, which is just 3, as the square root and the square cancel out, which then gives you the hypotenuse. So then you get 1 plus 3 equals h squared, and we're trying to solve for h, not h squared. Therefore, we square root both sides, and then you get h equals the square root of 4, which is 2. Now, the other way of solving this is using trigonometry. So now that we have the given value of root 3, and we need to solve for the hypotenuse, recall that sine theta is the opposite side over the hypotenuse. Therefore, the sine of 60 degrees equals to the square root of 3 over the hypotenuse. Let me just write that down. Sine of 60 degrees equals to root 3 over the hypotenuse. Like we did with tangent theta, let's solve for h. Multiply both sides by h, so that on the right side, the h is canceled out, and now you get h in the numerator. Divide both sides by sine of 60 degrees, and sine of 60 degrees is root 3 over 2. Therefore, h equals to 2. Alright, now that we covered the trigonometry portion, let's go to sig figs. Suppose we were given a number such as 0.005083300. Now, let's talk a bit about sig figs. These three zeros over here are called leading zeros. Leading zeros are not considered significant when counting sig figs. And also, now, let's talk about these numbers, the non-zero digits. Non-zero digits are any digits from 1 to 9, and they count as sig figs. So, we already have 3 sig figs. Now, let's talk about the trap zeros. Do you see how the 0 is trapped between these two non-zero digits? Any 0 that is trapped between 2 non-zero digits is considered a significant digit. And lastly, we also have trailing zeros. Trailing zeros after the decimals are not the same as before the decimal. I'll explain in a bit, but basically, trailing zeros are also considered significant. So, let's say we were given this number, 1000. How many sig figs does it have? Well, even though these guys are trailing zeros, like I was about to mention, these don't count unless there were a decimal place. So therefore, this 1000 over here only has 1 sig fig. Now, suppose I added a decimal place, now it will be considered 4 sig figs. Alright, now let's talk about the rules for adding sig figs, subtracting sig figs, and multiplying and dividing. The rule for subtracting and adding sig figs is that your answer, or the sig fig rule for adding and subtracting numbers is that you go to the lowest decimal place possible. So I noticed how 1.61 goes to the 100th place, whereas 0.5 goes to the 10th place only. Therefore, my answer will go to the 10th place. 1.61 minus 0.5 gives me 1.11. However, because of the rules for sig figs for adding and subtracting, our answer will be 1.1. Alright, now let's talk about multiplication and division. Say I had 3.00 times 15. So, notice how 3.00 has 3 sig figs, whereas the 15 only has 2 sig figs. So, as a result, my answer will only have 2 sig figs. When it comes to multiplying and dividing, the number of sig figs matters. When it comes to adding and subtracting, the number of sig figs don't matter. So, let's do this. 3.00 times 15 gives me 45. And we just leave like this because that is the lowest number of sig figs possible. Okay, now let's talk about the difference between a vector and a scalar. A scalar is a quantity with magnitude only. This ranges from temperature, mass, time, speed, distance, or even like flux, work, energy, which we will learn later. And a vector is like that, only now you include direction. Some examples include velocity, displacement, acceleration, force fields such as electric fields and magnetic fields, forces, and momentum. So, let's say I had this quantity, 5 meters per second. This will be considered speed as I don't have the direction, rather I only have the magnitude. However, say I had 5 meters per second east, then this will become a vector as it has both the magnitude and direction. Alright, so on the topic of vectors, let's talk about this adding and subtracting vectors. For starters, let's say I had vectors A and vector B. I want to add them up. So what is A plus B? The rule for adding vectors is that you add the tail of the vector getting added to the tip of the first vector, the tip being the head. Therefore, as a result, A plus B will give me this. And the sum of these two vectors will give me this vertical vector over here. And I get a right triangle. How nice. Now, one thing I forgot to mention before doing this is that the way we represent vectors, when you're typing, you would either italicize or bold the letter you're typing. However, when we're handwriting it, let's say we had vector A, I would add an arrow like so. When representing vectors, and you must add an arrow to indicate that your quantity is a vector. Now, let's talk about subtracting. Say now instead of A plus B, we get A minus B. Well, what is A minus B? A minus B is the same thing as A plus negative B. So the question really becomes, what is A plus negative B? Well, to do that, because it's negative B, we must flip the B vector around in the opposite direction, a complete 180 degrees. Therefore, now we get A like this, and now we get negative B as opposed to positive B. Now the rest is the same, add tip to tail, and then you'll get your resultant vector. Like so. I know this image is a little unclear, but basically what happens is we have the vector, we have vector A here and vector B here. And then our resultant vector is this. Now that is all for the basics. In my next video, I'll be just discussing about kinematics, the study of motion disregarding the forces that act on the mass. I hope you enjoyed learning with me as I enjoyed learning with you. I hope this was impactful for all of you. Thank you. I will see you all next time.